Welcome to clickmyproject.com. Our product title is Analysis and Design of Modified Half-Bridge Series Resonant Inverter with DC link Neutral Point Clamp Cell. Now we are going to discuss about our product abstract. In this paper, a modified half-bridge resonant inverter topology with a DC link neutral point clamped cell is proposed. A pseudo-symmetrical voltage cancellation PWM method and a control strategy was introduced. The proposed topology can maximize the inverter output power factor and minimize the variations of the switching frequency. In addition, most switches are clamped to off the DC input voltage at turn off, increasing the overall efficiency of the systems for a wide load range. The efficiency of the proposed inverter is improved up to 70% and light load condition compared with that conventional HP inverters. Full bridge and half bridge resonant conversion topology have been widely applied DC to DC converters for switched mode of power supply systems, photovoltaic power system, and battery charges electrical vehicles. Along with these application introductions, heating systems are typically exempt. DC to AC inverters that use both topologies. Recently, contactless inductive power transform systems, mostly developed for low power applications, have been shifted to higher power levels such EV2 charges. The main purpose of the power conversion systems, doubtless the efficient energy transfer from the source to load the little loss. Thus, resonant converters inverters topologies are a good solution to minimize the losses through switching for the wide load range. In the studies have focused on event increasing the efficiency over a wide load range, especially from the middle to low load ranges. Now we are going to discuss about our product flow diagram. So we are giving the input voltage for source for DC voltage for 400 voltage DC voltage, and then we are going to this applied for the modified half bridge like half bridge resonant inverters topologies with the DC link for going to the ZVS zero voltage switching. This process when the two switches pairs exist, which one switch of bridge leg and one switch of the NCC complementarily operate with each others. One switch pair is controlled by varying the duty cycle during off switching periods, and another pair is fixed by off duty cycles during one switch periods. Because the operations is proposed series resonant inverters topologies. This inverter topologies offers the attractive advantage of the conventional HP series resonant inverters topologies. First, the pseudo AVC control method, which shows a similar characteristics of the AVC control method, and for HP inverters can be implemented in the HP inverters topology. The proposed and then we have applying the PWM pulse width modulation is voltage step shaped wave according duty cycles ratio, and therefore the power factor PF is inverted output and switching frequency is related conditionally at the time is related operation mode and main derivation of the proposed inverter topologies. So in the design procedure, resonant parameters and then performance of result HP controller, ADC controller like that PWM controller, and then inverters term of the inverters output to total hormone distortions and PF compared to the optimum control strategy for the topology systems various losses experimental result with present with 6 and validate the analysis of the output. Now we are going to discuss about our running procedure for this product. So I have the head theme designing for the file name was resonant. I have developed the designing process. I had to just go through the running how to run this project. So first of all, design file and new model. So So open this file. We have getting from the parameters values all for simulating library browsers. We are getting from any all parameters value tools from here. I have and then you have to then finish your designing process, and then you have to go to the running the processor. So running the processor, so the output will be displaying the scope functions. We have to zone in only for scope. So I have given the input for the DC voltage for 400, and then I will be get output voltage for nearly 250 VRMS. That's flexible for that how bridge unit process. So this is the inverting process only. So I have to see so my output was this scope. This is output for the in load, and the it will be take the simulation time. So it's going to simulation time. So this is output for that. Now I have to show my output for the scope. So this is output for that. So output functions I will clear give the output function nearly 250. I have show my input also. So this is the input functions. So I give the input for the 400 and get the output value for 250 nearly. This is the load, current load. This is the output for the inverters. So nearly will be it will be give the 250. So is a good output